going to quickly correct these ones. Now remember, we have to multiply by the square of the denominator. Now the reason for that is the following. If you have, for argument's sake, 6 divided by minus 3, which we all know is minus 2, and minus 2 we all know is smaller than, for argument's sake, 3. If we cross multiply up to minus 3, so we get 6 less than minus 3 times 3, we get 6 is less than minus 9, and in this case we'd have to reverse the sign because 6 is in fact bigger than minus 9. However, this wasn't a negative number, and 6 divided by 3 and 2 is less than 3. If we cross multiply this time, it's plus 9, and the sign wouldn't have to reverse. Because we don't know whether x plus 2 is positive or negative, what we have to do is we have to multiply both sides by a guaranteed positive number as to not affect the balance. So, long story short, because we don't know whether or not to change the sign around, what we do with questions like this is we always multiply by the denominator squared on both sides, like so. This, you're essentially multiplying both sides. Let's say 3 is bigger than 2. You're multiplying both sides by a guaranteed positive number, like 10, for example, and you see that that never affects the balance because multiplying both sides by a positive number, the sign never needs to be changed. So that's what we did here. And what we're going to do next is this x plus 2. We cancel with that. One of the x plus 2's here. Remember, there is 2 of them because it's squared. Okay. And then, so we're going to multiply this out. We're going to get 2x squared plus 4x. Sorry about that, John, there. Plus 4x plus 1x and plus 2 less than, this is x, x plus 2 and x plus 2. And if we multiply that out, we'll get x squared plus 2x plus another 2x plus 4 all over 2. Grab that 2. 2 is a positive number, so you're allowed to multiply it across. As an example, 10 divided by 2 is smaller than 6. I'm basically saying 5 is smaller than 6. Bring that 2 upwards. 10 is less than 12. Basically, you're allowed to bring up a positive number and multiply it. It's no big deal whatsoever. Okay, so this is 2x squared plus 5x plus 2. Multiply that by 2, and you get 4x squared plus 10x plus 4 less than x squared plus 4x plus 4. Bring over the numbers and take them away. So you're going to get 3x squared. 10x take 4x is 6x. And the 4's cancel. Now, this here is a U-shaped function. But we do not know where this U-shaped function hits. We have no idea where it hits. So we're going to solve this equal to 0. So it's going to be 3x into x plus 2 equals 0. If you multiply it back out, you get 3x squared plus 6x. You're going to get 3x equals 0, which means x equals 0. You're going to get x plus 2 equals 0, which means x equals minus 2. So it's sort of like this. 0 minus 2. You look at this here, and you want it in between because you want to be less than 0. So that means all the numbers between minus 2 and 0. Minus 2 less than x less than 0. That's your answer for that one. Okay, next one. Find the following answers. We bring over to 15 and we get 6x squared minus 1x. Oh, typical. 6 times 15 minus 90. two numbers that multiply to give me minus 90, but add to give me minus 1, minus 10 and my plus 1. 6x squared minus 10x plus 1x. Ooh, no, that's a 9. There we go. I don't know what happened there. Greater than 0. Take out 2x in common, and you get 3x minus 5. Take out 3, you get 3x minus 5. Now, if you look at this graph here, this here is a u-shaped function because it's an x squared. It's positive x squared. So once again, we just have our standard u-shaped function, and we don't know where it pops up. We don't know what side it happens on. So what we're doing currently is we're solving it actually equal to 0. Okay, so we get 2x plus 3, 3x minus 5 equal to 0. We're going to get 3x minus 5 equals 0, 3x equals 5, x equals 5 over 3. 2x plus 3 equals 0, 2x equals minus 3, and x equals minus 3 over 2. Now they're actually both positive, so technically speaking, it's over here like this. Oh wait, no, they're not both positive. Oh, what am I thinking? They're this way. So that's 5 over 3 right here, and that's minus 3 over 2 right here. Now this time, we want it to be bigger than 0. Okay, so this is bigger than 0. This part here in blue is the smaller than 0 area. So these two green parts here, these ones are the bigger than 0 area. So you can write them as two ways. You can write them as x smaller than minus 3 over 2 and x bigger than 5 over 3. Some people in the class like to write it like this, where they spin this one around and they say minus 3 over 2 is bigger than x, and the answer you guys will write is minus 3 over 2 bigger than x bigger than 5 over 3. That's an acceptable answer, and the two of these combined are acceptable answer as well. Okay, next thing we're on is on this one here, the one on the top right, and what we're going to have here is this one here is an n-shaped function because it's a minus x squared. Okay, if we want, we can multiply both sides by minus, and when you multiply both sides by minus, you're going to get x squared minus 16 is bigger than or equal to 0, which is actually a u-shaped function, like so. Okay, this u-shaped function, we don't really know where it crosses, so we're going to solve this equal to 0. It's actually the difference of two squares. Then you're going to get x equals minus 4 and x equals plus 4. That's minus 4 and that one's plus 4. And lo and behold, it's meant to be bigger than 0. So it has to be these two regions here on the outside where the x-axis is bigger than 0. So you're going to have is x smaller than or equal to minus 4 or x bigger than or equal to plus 4. Some people might write it like this, where you'll say minus 4 is less than or equal to x. Oh, sorry. Spin it around. Minus 4 is bigger than or equal to x. You're allowed to reverse the signs, as in 4 is smaller than 5. Reverse the signs. 5 is bigger than 4. And that in turn is bigger than or equal to 4. Okay, hope that's all right with you. Okay, so that's good. So, two good answers there. Either this one here or this one here. Now these ones are modulus. Modulus sign means that it can never, ever be negative. So, safe way to do these is to square both sides. So we'll just get 3x minus 2 by 3x minus 2 equal to x squared. And then you're just going to get 9x squared minus 6x minus another 6x plus 4 equals x squared. 8x squared minus 12x plus 4 equals 0. I'm going to divide both sides by 4. You can solve this using the reference number system. So you're going to use a minus 2 and a minus 1. Oh, excuse me. There you go. Nothing funner than a bit of COVID maths, lads. All the rage. 2x equals 1, x equals a half. So a half or 1 is the answer. Now, if you're wondering whether you're correct or not, you could always sub it back up here. So x equals 1, no hassle, and that could be 3 times 1. 3 times 1 take away 2 is 1. The modulus of 1 is 1. So you can check your answers really quickly, whether they're correct or wrong. You do the same thing with a half. It's all the same. Question 2 is going to be pretty much the same same job. Square both sides. Now this time when you square both sides, it's going to be 2 times x minus 3. You have to square the 2 and the 3, x minus 3. So it's 2 times 2, x minus 3 by x minus 3. And on the other side is going to be 4. So 2 times 2 is 4. That equals 4. Then you can multiply this part out. And it's going to be x squared minus 6x plus 9. You can divide both sides by 4 right now if you wanted. Some of you might not have done that, which is fair enough. You bring this 4 out the other side. You get plus 32. Divide both sides by 4. And that's fair enough. Now, if you did divide both sides by 4 that time, that goes once, that goes once. You bring the 1, take it away from the 9, and you get exactly the same thing. So it depends what route you decide to take. Either way, this is x minus 2, x minus 4 equals 0. Two answers are 2 and 4 respectively. Okay, let's keep going. All right, lads, this is easy peasy. You bring this out your side, you're going to get a squared minus 2ab plus b squared greater than equal to 0. You can pretend that the b doesn't exist if you want to know how to solve this. It's going to be a squared minus 2a plus 1 greater than equal to 0. If you were to solve this using the reference number, you're going to get a minus 1, a minus 1. So that means up here, this will be a minus b, because you removed the b squared and placed it with a 1. If you multiply that back out, you'll see it's the same thing. And any perfect square is bigger than 0. So if this is a perfect square, and all perfect squares are bigger than or equal to 0. Okay. Now let's try this one. We all need a common denominator. Now, specifies that these two numbers are guaranteed positive. That's important. So let's give them a common denominator. A on top, A on the bottom, B on the bottom, B on top. We now have a squared plus b squared over a common denominator of ab greater than equal to 2. I'm allowed to cross multiply the ab without worrying about changing the sign. Reason being, it's guaranteed positive because both these numbers are bigger than 0. So we get a squared plus b squared greater than 2ab. We bring it over, and long and behold, it's the same as the last question, where it's going to be a perfect square bigger than or equal to 0. Hence, we proved it. Okay. Oh, here's another one. I wonder, did I skip one on this page? No, I didn't. So, this one here looks to be an awkward one. Okay. So there's a way of doing this, okay? What I'm going to do is I'm going to concentrate on this part here. See this part here? Just going to concentrate on that. I'm sort of wondering what type of perfect square will result in this part. So if I go for x plus 2 squared, and that means x plus 2 multiplied by x plus 2. And we all know that that'd be x squared plus 4x plus 4. Okay? Now, that's perfect, right? But I have x squared plus 4x plus 6. So if I add on an extra 2 at the end, these two things are the same. But then if I convert this back into x plus 2 squared plus 2 greater than 0. Okay? This is what's known as completing the square. Okay? And it's a good way. It's a good method for doing this. I might give a class dedicated to this pretty soon. So I'll put that up on Google Classroom as well. Completing the square would be a good class to do in my absence. Okay, so we have this is a perfect square guaranteed to be positive. This is a positive number guaranteed to be positive. Both of them combined are guaranteed number guaranteed to be bigger than 0. Now, this is a nice question here. Write root 32. So that is 32 to the power of a half. The 32, however, is 2 to the power of 5 when we shift factor. And then we use the multiplication rule of indices and we get 5 over 2. Excellent. That changes this question into 16 to the power of x minus 1. Oh, look, they're being really smart here. They're doing 2 root 32. So it's going to be 2 to the power of 1, which is this 2 here. And the root 32 is going to be 2 to the power of 5 over 2. We use the addition rule of logs, which is 1 plus 5 over 2, which will get you 7 over 2 when you use the calculator. This 16 is not compatible with the 2, so I'm going to shift fact 16 into 2 to the power of 4. 16 is 2 to the power of 4. And then I'm going to use the multiplication rule here. I'm going to get 2 to the power of 4x minus 4 equals 2 to the power of 7 over 2. Both powers equal each other. We're going to get 4x minus 4 equals 7 over 2. Bring over the 4. We're going to get the calculator out. Alright, so I'm just going to get that 7 over 2. I'm going to add it to the 4. I get 15 over 2 right here. Okay. I'm going to bring down the 4. So it's 15 over 2 divided by 4. I'll divide my answer by 4. 15 over 8. Now, if you're not sure about your answer, go back to the top, all right, and do 16 to the power of, replace x with 15 over 8. Take away your 1, and your answer is 11.31. And then on the other side, just enter 2 root 32 into your calculator. That's also 11.31. You know your answer is guaranteed correct. And only took a couple of seconds to correct that. Now, this one here, we did these recently. 3 to the power of x equals y. Square both sides. 3 to the power of x squared equals y squared. Use the multiplication rule of indices. And 3 to the power of 2x equals y squared. This makes that y squared minus 12y plus 27 equal to 0. Reference number of 3 and 9 respectively. And what you're going to get is y equals 3, y equals 9. But this is 3 to the power of 2x equals 3 to the power of 1. 3 to the power of 2, oh sorry, not 3 to the power of 2x, 3 to the power of x. Silly me. X equals 9. 3 to the power of x equals 3 squared. X equals 2. X equals 1. There you go, 1 and 2 respectively. Now, what's the last one we have? Oh, this one here. Hopefully it's the last one. Alright, that's good. We're 20 minutes in. Now, convert them to trees. Shift fact both sides. You're going to get 3 to the power 3 to the power of x. Replacing 27 with 3 to the power of 3. Replacing 9 with 3 squared. And I think I'm going to get 3x equals 2. And x therefore equals, so it's going to be 3 to the power 3x equals 3 to the power 2. Power equals power. X not y is 2 over 3. This one here I'm going to shift fact 64 and it's going to be 2 to the power 6. You wonder what I mean by shift fact? I press 64 equals shift fact 2 to the power 6. Now I'm just going to get x minus y equals 6. Now if I'm not too sure about this, what I can do is I can replace x with 2 over 3 minus y equals 6. I'm going to bring the y to the right, 6 to the left, and I'm going to get y equals 2 over 3 minus 6. So 2 over 3 take away 6 minus 16 over 3. Now, if I want to check my answer, here's what I'm going to do. 2 to the power of whatever x is, so 2 to the power of whatever x is 2 over 3. 2 over 3. Take away whatever y is. So y is minus 2 minuses 16 over 3. Press equals. The answer is 64. Yes, it's meant to be 64. The end. Answer verified. Done. 22 minutes.